Hi, once again, you're welcome to another lesson in mathematics. Today, we'll be looking at addition and subtraction of unlike fractions. Addition and subtraction of unlike fractions. If you recall, last week we did something in fractions, and I did mention that fraction is quite a vast topic. It's a kind of large topic, and we will just keep exploring it concept by concept because there are a lot of sub-concepts in fraction. So for today, we'll be looking at addition and subtraction of unlike fractions. I'm sure we looked at like fractions in our previous lesson, and we found out that addition and subtraction of like fractions is quite easy. It's quite easy because like fractions are those fractions that have the same denominator. And what you simply do to add such fractions is you add the numerators, and then whatever answer you get over the denominator, you retain the denominator. You just copy out the denominator. Okay? And if you are doing subtraction, you simply subtract the numerators, the smaller one from the bigger one, and you write it over the denominator. Denominator is the same, it doesn't change. Okay, but unlike fractions, it's not so straightforward. Okay, unlike fractions, the calculation of the addition and subtraction of unlike fractions is not so straightforward as that of the like fractions. Here, what we try to do in order to be able to calculate is we need to work on the fractions and create a common denominator for them. We need to create a common denominator. That is, we need to work on the fractions and bring them to the point where the denominators of the two fractions are the same number. Okay, so let's take an example. Okay, let's go back to like fractions, just refresh our memories, and then we move on to unlike fractions. Okay, so we have something like 1/5 plus 2/3. This is 1/5 and this is 2/5. So since they have the same denominator, these are like fractions. Remember, you're just simply adding numerators together. So it gives you 1 plus 2/5. You just pick one of the 5 because it's the same number. And 1 plus 2 is what? 3. And that's your denominator rather. So it's as straightforward as that. It's a concept that is even taught in like grade 1, primary 1. Okay, so I'm just doing this to remind us of where we need to go to in order to solve unlike fractions. So for an unlike fraction, we will have something like maybe 1/5 plus let's say 2/7. Okay, let's start with something smaller. 1/3 plus 1/4. Yeah, let's start with this. So example 1. Okay, so in order for us to be able to add these two numbers, remember they don't have the same denominators. That's why they are called unlike fractions. In order for us to be able to do this addition, we need to try and make them have the same denominator. Create the same denominators. So you could try and create the same denominator for the two numbers. So how do we get the same denominator for them? You find the LCM of the two numbers, of the two denominators. Okay, so in order for you to, sorry, this is looking a bit off. I'm going to rewrite that. Okay, I think that's a bit better. All right, so we need to find the LCM of the two denominators. Remember in our previous lesson, we learned about LCM, that is lowest common multiple of numbers. And what does that mean? It means the smallest number that 3 and 4 can divide without a remainder. The smallest number that 3 and 4 can divide into without leaving a remainder. For example, 3 can divide 3. So that means 3 is a multiple of 3. 6 can be divided by 3. That means 6 is a multiple of 3. 9 can be divided by 3. That means 9 is a multiple of 3. It goes on and on. 12 is there, 15 is there, 18 is there. Now if we come to 4, 4 also is a multiple of 4. 8 can be divided by 4, so 8 is a multiple of 4. 12 can be divided by 4 and it's a multiple of 4. 16 can be divided, 20 can be divided, 24, and on like that. So those numbers I just mentioned are multiples of these denominators. Now what we're going to look for is among those numbers that we just looked at now, we are going to look for the ones that both 3 and 4 can divide without leaving a remainder. And among those ones, we are picking the one that is the smallest. We don't want to go and pick a very big number that may give us problems when we're trying to do a calculation. So we pick the smallest among those different multiples of these two numbers that the two of them can divide at the same time without leaving a remainder. Now what we usually do to get such a remainder is to use the long division method. Though there is a shorter way to get it, but I will just quickly show you the long division method. It's something we already looked into. So since you have two numbers, you're going to extend your line like this to have two columns. So here you have 3 and here you have 4. These are the two numbers, right? Now you start dividing. What numbers you use are called prime numbers. They are prime numbers that you use. Those are numbers that only themselves and 1 can divide them without a remainder. And the examples of those numbers are 2, 3, 5, 7, 11, 13, 17, 23, 19 is there as well. Okay, those are some numbers. No other number can divide these numbers without leaving a remainder except 1 and themselves. Okay, so those are the kind of numbers we use when we are trying to find out the LCM of numbers. So the lowest, the smallest prime number we know is 2. So we're going to start with 2 because already we see one number here that can divide without a remainder, and that number is 4. So let's do this. 2 divide 3, it can't go, so you write the 3. It's not working. So 2 divide 4, how many times do 2 go into 4? It's 2 times. So you write it, right? That is gone. Now we still see 2 appearing again, so you repeat 2. 2 divide 3 is not going to work. There will be a remainder. We don't need that. So you write 3 down again. 2 divide 2, that would be 1, right? So now we have 3 and 1 left. What prime number we divide through these two numbers? 1 we know is, it doesn't really count when it comes to division, right? So the next number we're using here is 3. So 3 divide 3, 1. 3 divide 1. You repeat that 1. It's not even going through. Okay? So at the end of the day, what do? You multiply the prime numbers that you used in dividing. So that will give you 2 times 2 times 3. 2 times 2 is 4. And 4 times 3 is what? 12. That means the lowest number that both 3 and 4 can divide without a remainder is 12. That's the lowest common multiple. Now let me quickly show you something. Assuming we didn't go through this long division process, we could have just done 3 times 4. 3 times 4 gives you what? 12. But let me tell you, there's an issue with that because sometimes you are not always lucky to come up with the actual lowest common multiple. The thing is, you will definitely come up with a common multiple of the two numbers, but it may not be the lowest one. There are times the number you get, you will have to still reduce it, to get to the lowest common multiple. So, but if you use it and you know how to reduce to the lowest terms, okay, reduce your fraction or your answer to the lowest term, you still get the same answer. So this is one shortcut. You know, it's a very short way of quickly getting your LCM. Just multiply the two denominators together. You get a common multiple. I won't call it LCM. Sometimes it could be the lowest one. Some other times it's not the lowest one. But definitely you're going to get a number that these two numbers, these two denominators can divide when you multiply them. It will give you a number the two can divide, definitely. And you can go on and use that. But if you want to get the real LCM and be sure it's LCM you're using, you use this method. Okay? So next we're going to see how the face of this, I'm going to take this off and then we'll continue from here. Okay? Because we need some space. So we've got the LCM as 12. Now what do we do next? We divide the LCM by each of the denominators and we multiply them by the numerator. You start with the first fraction, you divide the okay, let me state this quickly, that the LCM you got is now going to become your new denominator. Remember we said that what we are trying to do is create the same denominator for the two fractions. Okay, that's what led us to going to look for the LCM, to make sure we get the same denominator. Because once you have the same denominators, it becomes easy to add or subtract the fractions. So that's what we have ended up doing now. So 12 will now become the denominator of the two fractions. So here is how it will now go. You have 12 divided by 3 is 4. 4 times 1 is 4. So you do 12 divided by 3. You put that in a bracket times 1. Okay? That's for the first fraction. And for the second fraction, you put your plus in the middle. It will be 12 divided by 4 times 1. Okay? So we have our common denominator. Now we just want to get the new numerators so that we can do our addition. So what do we do next? We have now 12 divided by 3, that gives us let's take this back a bit. 12 divided by 3 is 4. So you have 4 times 1. We can put this whole thing in bracket, plus 12 divided by 4 is 3. That means 3 times 1. You have everything over the new denominator, which is 12. This is the new denominator. Okay? So now you have 12 divided by 3 gives us 4 times this one. We write that. Write your plus sign. 12 divided by 4 is 3 times 1. That's what we have written down there. Okay? Now we're ready to open the two brackets. We're ready to open the two brackets. 4 times 1 is 4 plus 3 times 1 is 3 over the new denominator, right? Which is 12. And that gives us 4 plus 3 is 7 over 12. Okay, so that is how we do our calculation for unlike fractions, our addition of unlike fractions. Okay, we are going to take another example to see how to have a better understanding of this. All right, the second example we're going to look at here is 2/5 plus 1/6. 2/5 plus 1/6. If we look at the two fractions, we can see that they don't have the same denominators. They have different denominators. So we need to first try and get a common denominator for them before we go ahead and add. So to get the denominator, a common denominator for the two of them, we're looking for the LCM of the two numbers. Remember, this means lowest common multiple. That is a number that 5 and 6 can divide without remainder. And that number has to be the smallest among the group of numbers that 5 and 6 can divide without remainder. So let's go on. We use a long division method. Okay, we use this division method rather to find the LCM. So here we have We have 5 here, we have 6 here. Now if we look at the two numbers, 5 is an odd number, 6 is an even number. And we know that 2 can divide through any even number. So 2 as the smallest prime number, we start the operation. So we divide by 2. 2 divide 5, there will be a remainder, so we're not going to use it. We just simply write out the 5. Okay? Then 2 divide 6, or 6 divided by 2, that gives us 3. You get 2 can go into 6 3 times, and there's no remainder. Now we have two numbers, we have 5, we have 3, and we know that these two numbers are odd numbers. 3 can divide either of them without giving us a remainder. So we're going to leave 2 because 2 can't help anymore. We try the next prime number, and the next prime number is 3. Okay, remember prime numbers are those numbers that only themselves and 1 can divide them without a remainder. So the next prime number to try here is 3, and we know that 3 will work because there's already 3 here. So 3 divide 5, it won't work. There will be a remainder, so we won't bother. But 3 can divide 3, so 3 divide 3, it gives us 1. Okay, so the only number we're left with here now is 5. Because once you get to 1, 1 is the end of the road for whatever number is giving us 1 after division. After division, if you get any number that is giving you 1, you have reached the end of the road for that number. Okay, so you focus on the other real numbers that are left or that is left. So right now it's only 5 that is left. What do? We do 5 divided by 5. It gives us 1. Okay, so that's where we stop. The next thing you just do is your LCM will be 2 times 3 times 5. 2 times 3 times 5. 2 times 3 is 6. And 6 times 5 is what? 30. 30. Okay, so the LCM here is 30. Now we come back to our fraction. We come back to our fraction to continue our calculation. So just for space, 2 over 5 plus 1 over 6. So our LCM is 30. Okay, so 30 divided by 5, you do 30 divided by 5 times 2 plus 30 divided by 6 times 1. Okay, so that gives us 30 divided by 5 is 6. 6 times 2 plus, let's bracket this, 30 divided by 6 is 5. So you have 5 times 1, everything over 30. Right? So this gives us the final thing we have here is 6 times 2 is 12 plus 5 times 1 is 5 over 30. So 12 plus 5, the final answer is 17 over 30. So that's how we do our addition of unlike fractions. Okay, so the next example we're going to look at is how we do subtraction of unlike fractions. Subtraction of unlike fractions. So if you look at the example we have on the board, the fractions there involved are fractions with two different denominators. The two denominators are different. So this process is also exactly like that of addition of fraction. The only difference here is instead of adding whatever you come up with at the end of the day, instead of adding them, you simply subtract. That's just the difference. Otherwise, the process is exactly the way it is when you are adding unlike fractions. Okay, so for a start, we're going to look for the LCM of these two numbers. So LCM, let's start with that. Remember how we do this, right? So you have your 3, you have your 5. You can write your 5 first or 3, doesn't really matter. Okay, so let's look at these two numbers. None is even number, so 2 won't work. Okay, so the next prime number we can try is 3. So 3 divides 3 is 1. 3 can't divide 5 without a remainder, so we repeat 5. So the two numbers we have now are just 1 and 5, so you ignore 1. Like I told you, it doesn't make any difference. So the only real number there now is 5. So you use 5, you repeat this one, 5 divided 5 is 1. Now, remember also I told you that once you get to 1, you have reached the end of the road of that particular number. Now, both numbers now give us 1, 1. That means that's the end of it. So what do we do next? We get the LCM, which is 3 times 5, and that is what? 15. The LCM is 15. Now let's come to a fraction. Okay, again, I'm going to move it this way so that we have space for calculation. 4 out of 5, that's 4/5, minus 2 out of 3. Okay, so now we have our LCM, which is the new denominator, and that is 15. Okay, so what do we do? As we have always done, I'm sorry for my crooked line. Okay, let's just wow, it's really coming out funny. Okay, let me try again. So you have 15 as the new denominator. So now for the first fraction, what do you do? 15 divided by 5, that's what we do. 15 divided by 5 multiplied by 4, right? Minus, this is just the difference. Here you have 15 divided by 3 times 2. You see, just the only difference we have here is the minus sign in the middle. That's all. Otherwise, it's exactly the same thing as the addition method. So here we have 15 divided by 5. That gives us 3 times this 4 now. Okay, you can put that in the bracket. You write your minus. 15 divided by 3, that gives us 5. Then times the 2. You can also put that in bracket. And then write your new denominator, which is 15. The new denominator for the two fractions, right? Okay, so the next step here is opening the brackets. So you have, let me take this down. I want everything to be jumped. So 3 times 4 is what? 12. You bring your minus sign. 5 times 2 is what? 10. And remember your new denominator, 15. Right? So this becomes 12 minus 10 is 2. And your denominator is 15. So that is the answer. That's your answer. I hope it's simple. Yeah, let's take one more example. So the second example for subtraction of unlike fractions is 3/4 minus 5/8. Okay, so let's see how this goes. First, we calculate for the LCM, right? Now you have 4 here, you have 8 here. 4 and 8 are two different numbers, so we want to see what number is there that the two of them can divide into without a remainder. So both numbers are even numbers, so that means 2 can go. So 2 goes to 4. 2 times 2 into 8, that gives you 4. So 2 can still go because we have 2 here. 2 divides 2, 1. 2 divides 4, it gives you 2. Here we go again with 2, so we write the last 2, 1, 1. Now we've reached the end of the road. So what will be our LCM? Our LCM will be 2 times 2 times 2. Okay? So 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. Okay? So 8 is our LCM. I hope we can see that. Our LCM is 8. So now that we have our LCM, we're going to go ahead now. Let's use this space for our work. So it's write 3/4 minus 5/8. Now I know looking at it literally, one would be like tempted to think that this other fraction is bigger than this. But let's work it out. Once we have common denominator, you can figure out which is actually bigger. Okay, so let's go on. Now we have a new LCM, or the new denominator rather, which is 8. So let's write our 8. Get on my crooked line again. Okay, can manage that. So our new denominator is 8. Okay, so let's go. So the first part, you have 8 divided by the first denominator multiplied by the numerator, minus 8 divided by the second denominator multiplied by the numerator. Okay, so let's continue. We have 8 divided by 4, that gives us 2. This needs to go down, else we're going to have. So you have 2 times these 3. I put them in bracket. Let's write our 8 there. Minus 8 divided by 8 is 1. So you have 1 times 5. Okay? So here we have 2 from 8 divided by 4. That gave us this 2 times this 3. Here 8 divided by 8 is 1 times this 5. Okay? So you continue to write your denominator, the common denominator, which you arrived at. So what happens next? You open the brackets. Open the brackets. So 2 times 3 is what? 6. Minus 1 times 5, 5 over 8. So what do you have? 6 minus 5 is what? 1 out of. So that's our final answer. 1/8 is the final answer. So let me just quickly do a recap. Actually, the only thing you need to do here is try to find the LCM. And after you find the LCM, which will now become the new denominator for the two fractions, you divide that new denominator by the old denominator. You divide the new denominator by the old denominator and multiply it by the numerator. Divide the new denominator, which is the LCM, by the old denominator and multiply by the numerator, the number on top. You do the same thing for the two fractions, okay? And then you go ahead and simplify. You use your Bodmer's rule, remember? You try to know which one you need to work on first before the other. At the end of the day, you arrive at your answer. It's an interesting concept, so just keep practicing. So for the LCM, I'll say it again, like, if you feel that looking for the LCM is challenging for you, you can just simply multiply the two denominators. You will get a common multiple, but it may not be the lowest common multiple. Remember when we did 3 and 4, we used LCM to get 12. But when we came and we did 3 times 4, it also gave us 12. We were just lucky. There are some cases you are lucky. You get the exact lowest common multiple. But it's not always the case. For instance, if you look at these two denominators here, 4 and 8, if you want to use that method of multiplying the denominators, you're going to get 32. And you know that when we use the LCM, we got 8. Remember, LCM is the smallest among those group of numbers that these two numbers can divide without a remainder. So if you get 32, it's going to give you big numbers to work with. But that doesn't mean you will get the wrong answer if you are able to do it right. If you get it right, get your steps right, know how to simplify your terms, you'll still get the correct answer. But then you will be working with bigger number, which will be more stressful than working with the lowest common multiple. Okay, so but if you feel this is challenging and it's going to make you miss out on the whole thing, you can just do 4 times 8, multiply the two denominators, and you go ahead and you do the rest. Okay, divide the denominator by the old one, multiply by numerator, and follow it step by step. Use your Bodmer's rule if you have to, or if you know how to do it, and then you arrive at your answer. You get your answer. Okay, I hope we've learned something today. For subtraction and division of unlike fractions, there's a method that I would also like to teach us, but that will be in another video. Okay, I'm going to make a separate video on that. Okay, that we call the butterfly method. Some of you that maybe finding this challenging would probably find that easier, much easier to work with. So in our next video, I'm trying to come up with something on that method, okay? So that it will help those who are not okay with this method of adding and subtracting unlike fractions. So I hope to see you again next week. Until then, stay blessed and stay safe.